Hello everyone, welcome back to WE Academy. So in this video, I'm going to explain model question paper of Introduction to Electrical Engineering of Module 1. So likewise, I will do it for Module 2, 3, 4, 5 also in upcoming videos. And also with an offer, so I'll tell you the important questions that you can expect in the examination of Introduction to Electrical Engineering for VTU examination, especially for first years. Those who are studying first year, that is second semester. So it will be really helpful. So without wasting time, so let's go to the model question paper of Introduction to Electrical Engineering. So before that, please do a like, share and subscribe to this channel. It will help a lot students to get outcome from the stress that they are having in the particular subjects. So it may helps the model question paper so that can see the model question paper. It will be having five full question. Sorry, it will be having 10 questions. In that, you have to write five full questions. Each model will be having two questions. You have to write it for any one full question. So module one, so I'm taking two questions. Likewise, you'll get in examination. So here question number one, two, any one full question you have to write it in the examination neatly, and you need to convey the answers in a booklets that evaluator should understand what you have written. Okay, so in that manner you have to write. So now you can see the first question with a neat single line diagram. Explain the various steps of power transmission and distribution system. So single line diagram means, so I wanted to tell you one thing that, so if any of the question which will be having a diagram, obviously the diagram that will be having a weightage of marks. So here they asked it for 6 marks. Obviously the diagram which will be carrying 2 or 2.5 marks. Later, you need to write neat steps, that is explanation. They asked you to write various steps. It will be having 5 steps, you'll get to know. But here, the steps will be having either 4 marks or 3.5 marks. So likewise, they will contribute the marks. Okay, and also you should be very careful that if the diagram is wrong, explanation is right, you'll get 0 marks. So that you need to draw a right and neat single line diagram. If you miss any one component, you'll get 0 marks. Okay. So without wasting now, you can see the single line diagram. It has a GS, nothing but generating station. Generally, it generates 11 kilovolts. So after that, we'll be having step up transformer at primary transmission side. Similarly, we'll be having step down transformer at receiving station called secondary transmission. Then we will be having one more step down transformer at the primary distribution side. Then again we'll be having one more step down transformer at the consumer side, that is called secondary distribution. The steps, various steps is nothing but you can see the steps now. So the first step we need to explain what is GS, that is nothing but generating station. So generating station is nothing but where electric power that will be produced by three-phase alternators that will be operating in parallel. Okay. Usually what will happen, the generating voltage that will be having 11 kilovolts. But for the economy in the transmission of electrical power, what happened? So you'll be using 132. You need to stepping up the voltage from 11 kilovolts to 130 kilovolts. So that electric power at 132 kilowatt is transmitted by three-phase, three-wire overhead system to the outskirts of the city. Okay, outskirts of the city. So this method or else this step is called primary transmission step. So again we'll be having, so you are generating a voltage and stepping up the voltage from 11 kilowatts to 132 kilowatts. Then again what you are doing, you are stepping down the voltage from 132 kilowatts to 33 kilowatts. So that point or is that step is called secondary transmission step. That is nothing but the primary transmission line usually terminates at the receiving station. So that will be usually what happens, that lies at the outskirts of the city, and also at the receiving station the voltage that will be reduced to 33 kilovolts with the help of step down transformer. So again, generating stations to step up transformer, and it forms primary transmission, then step down transformer, that is at the receiving station, called as secondary transmission. Then you need to do it for distribution side. So that the next one will be the fourth method is primary distribution. So primary distribution, you can observe the single line diagram, you can easily understand. Only these explanation is more sufficient, so that if you want you can take a screenshot, it will help you a lot. Okay. And also here the primary distribution, it is nothing but the secondary transmission line. So for the secondary transmission, primary transmission line will be terminates at receiving station. So here for the primary distribution, what happened, the secondary transmission line terminates at substation, their receiving station here, substation, where the voltage that will be reduced or a step down from 33 kilovolts to 11 kilovolts of the of three phase three wire system. So that 11 kilovolts to 132 kilovolts or 200 kilovolts in some of the textbooks, again 132 to 33, 33 to 11, then again 11 to 400, from 400 to single phase 230 volts that we are getting to our home, so that we can call it as consumers. So the last step is secondary distribution, you can see. So for the secondary distribution, the electric power from primary distribution line, that is 11 kilovolts, that is delivered to the distribution substation. Distribution substation is nothing but a secondary distribution. So these substations are located near the consumer localities. Generally, you guys can observe near the road, they will be placed a transformer called as distribution transformer. There you will be having 400 volts. That is step down transformer that you can observe near the road. So there 11 kilovolts to 400 volts, it is stepping down. Three phase four wire system, three phases, one neutral it has. So from one phase and one neutral to you'll be getting a supply to your home, that is nothing but 230 volts. So this much of explanation is more than sufficient. So you need to write a single line diagram, then you need to explain the generating station, primary transmission, secondary transmission, then again you need to explain primary distribution, then sorry, secondary distribution. Similarly, you can see next question, that is state and explain Kirchhoff's current law and voltage law. So I have a hint that here. So in a 2022 scheme, so you'll be getting formula handbook. So statement, if you are not remembering the statement, you just see in the formula handbook, they will be having the statement. Only the thing is that you need to write the explanation. But for knowledge purpose, you should know the statement of KVL and KCL. So KCL statement and KVL statement, they asked it for 6 marks, 3 marks for KCL, 3 marks for KVL. For that statement, we'll be having 1 mark. For explanation, we'll be having 2 marks. Same kind we'll be having. Or else one and off they will share. KCL statement is nothing but the algebraic sum of all the currents meeting at any junction equals to 0. So you can see, explanation means you need to explain sign convention. If the current is entering to the junction, you will be taking it as a positive. If the current is leaving from the junction, you are considering that as negative. You can also take vice versa, no problem. So here you can observe 1, 2, 3, 4, 5 currents with a different directions. So I1 is entering, so that you're writing plus I1, I2 is leaving, so that minus I2, minus I3, plus I4, plus I5 equals to 0. So you can read it as I1 plus I4. That is nothing but current entering to the junctions which are same as current leaving from the junction. So this explanation you need to write. And polarity. Current flowing towards the junction is positive. Current flowing away from the junction is negative. Okay. Similarly, KVL, you need to explain the sign convention and explanation. So you can see in any closed circuit, in any closed electrical circuit, the algebraic sum of all the EMFs and resistive drop is nothing but IR drop equals to 0. The algebraic sum of all the EMF and IR drop that will be equals to 0 is nothing but KVL, Kirchhoff's voltage law. For the sign convention, you need to understand here. So when current flows to the resistor, you should know a few basic things that, so in a voltage source, current which will be always flowing from lower potential to higher potential. Okay. So in a sign convention, so what if the current is flowing from negative to positive, you can call this as voltage rise, so that the voltage becomes positive. If the current is flowing from positive to negative, that is nothing but higher potential to lower potential. You can call this as voltage fall or else voltage drop, so that you can write minus V. I hope you're understanding. If the current is flowing from negative to positive, that is lower potential to higher potential, there will be voltage rise, so that plus V. If the current is flowing from plus to minus or else higher potential to lower potential, in that case you can call that as a voltage fall. So that is nothing but minus V. So that you can write plus V minus V in the KVL problems. Similarly, if you can consider the resistor, in resistor current which always flowing from higher potential to lower potential. Higher potential to lower potential. So that here we'll be considering if the current that will be flowing from positive polarity to negative polarity, the voltage that will be taking as a negative here, voltage fall plus to minus is nothing but in case of resistor, that will be considered as minus I into R, that is nothing but second polarity, minus IR. So you'll get to know the explanation. Few additional thing it is. Okay. So whenever while solving KVL, you need to find few steps to solve the KVL problems. So in that case, first step is you need to check direction of current. Direction of current. If they are only given the direction of current, that is fine. If they are not given the direction of current, you need to consider a priority as voltage source. If they are only given the direction of current, that is fine. If they are not given the direction of current, you have to give the direction of current. For giving the direction of current, you are considering a priority as a voltage source. In case of voltage source, the current which will be always flowing from lower potential to higher potential, so that I am considering this is the direction of current, lower potential to higher potential. Current I is flowing. Second point, based on this direction of current, based on the direction of current, based on the direction of current, mark polarities. Mark polarities. So polarities, while marking polarities, what you are doing, if there is a voltage source, anyhow you will get to know minus and plus. But if there is a resistor, the current which will be always flowing from higher potential to lower potential. So that you can see now, I is flowing here. So here in the case of this resistor, current is flowing from higher potential to lower potential. Similarly, here also higher potential to lower potential, the direction of current which always flows from higher potential to lower potential. So third point, if they are only given the loop direction, that is fine. If they are not given the direction of loop, give loop direction either clockwise or anti-clockwise direction. So here I am giving a clockwise direction loop. And the fourth point is based on the loop direction, based on the loop direction, based on loop direction, mark second polarity. Based on loop direction, mark second polarity. So first step, giving the direction of current. Second step, marking the polarity based on the direction of current. Third step, if they are given the loop direction, that is fine, or else you only have to give the loop direction either clockwise or anti-clockwise direction. And the fourth point, based on the loop direction, mark the second polarity, or else you can also mark the first polarity, no problem. But for my convenience, so I am marking a second polarity. So you can see here minus plus, loop direction is clockwise, the loop will be like this, the second polarity is plus. Similarly in the current, the second polarity is minus. Similarly, here also second polarity is minus. So now once after writing that, once after marking all these, you are writing the equation. That is nothing but with respect to the marked polarities. See now the voltage is positive, so that I am writing plus V minus second polarity minus which current is flowing I, so that I am writing minus I with respect to R1. Similarly, minus I into R2 equals to 0. Like that, you need to write the equations of closed loop direction with the help of KVL. So it is additional information that I am telling. So in the examination, what they asked you to write the statement and explanation, so that what can do. So you need to write a KVL statement and KCL statement. KCL statement and explanation is nothing but sign convention. We have to explain sign convention. Similarly, KVL statement and sign convention. So in KCL, you'll be getting two definition or statement. You need to write only both the statement, so that will be helped you to get full marks in the examination. Next, a third one. They asked the problem for 8 marks. Okay, so it is very many students are thinking like problems are very difficult, but actually, so for 2022 scheme, especially for introduction to electrical engineering subject, so they will ask you a simple numerical, so that nothing to worry about that. You can see here they're given a combinational circuit problem. That's nothing but series parallel combination of resistor parallel. Sorry, the series parallel combination of resistors problems they are asked. So here what happened? They asked a circuit of two parallel resistors. A circuit of two parallel resistors, which means that you only have to draw the circuit diagram. So for drawing the circuit diagram, also having weightage of marks for drawing circuit diagram. So you may get 1 mark for drawing circuit diagram, because they are not given any circuit diagram. So that a circuit of two parallel resistors. So a circuit which consists of two parallel resistors. So I'm drawing two parallel resistors. Circuit of two parallel resistors, that is 20 ohm and 30 ohm. Wherever you can write 20 ohm, 30 ohm, either 30 20 you can write, or 20 30 you can write. So this combination is connected in series with 15 ohm resistor, connected in series with 15 ohm resistor, and the entire the combination which is connected across voltage source V. So now read the question properly. A circuit of two parallel resistors having resistances of 20 ohm and 30 ohm connected in series with 15 ohm. So now you can see if the current through 15 ohm is 3 amperes. So V, the main current that will be flowing here, which divided as I1 and I2, and again the same I which will be come back. So current flows through the 15 ohm is 3 amperes, means they are given a total current I equals to 3 amperes. And what they asked you to find? In the first case, they asked you to find current in 20 ohm and 30 ohm. Current in 20 ohm is I1. So you need to find the value of I1 and I2. Current in 20 ohm and 30 ohm resistors. So to find this I1, you are applying current divide rule. Whereas the parallel circuit which has to find the divided current values, you need to apply current divide rule, which states that I1 equals to total current into opposite resistor. Opposite resistor is 30 ohm. Total current into opposite resistor divided by sum of the resistors, that is 20 plus 30. Whereas the value of current I is 3. So that 3 into 30 divided by 50 you will get. So you can get 9 divided by 5. That is nothing but 1.5 1.8 amperes you will get. Similarly, to find the value of I2, So you know the value of current I and you know the value of current I1. So that the total current I is given by I1 plus I2. So with the help of this, I can rewrite it as I2 is given by I minus I1. That is nothing but 3 minus 1.8. You will get 1.2 amperes. The first step that finishes current in 20 ohm and 30 ohm resistors. So next what they asked you to find the value of total voltage across the whole circuit. The second point, you need to find the value of voltage V, voltage across whole circuit. So to find this, you can use Ohm's law, that is nothing but V equals to I into R equivalent. Because you know the value of I, you can get the value of R equivalent, whereas R equivalent is given by the 20 ohm is connected parallel to the 30, so that 20 is parallel to 30, which is series with 15 ohm, so that plus 15. So you can get 20 into 30 divided by 50 plus 50. Okay, so that is nothing but 5 ones are 5 fours are 4 threes are 12. You can get 27 ohm R equivalent. So R equivalent is 27, so that you can get directly V equals to 3 into 27 is nothing but 81 volts will get. Second point that finished. And third point what they asked? In a third point, they asked you to find the value of total power and power consumed in all the resistors. So total power, third point, total power P is given by V into I, whereas you know the value of V is 81 and I is 3. So you can get 243 watts total power. So similarly, power consumed in all the resistors. So we'll be having three resistors. So that power consumed in 20 ohm resistor, P20 ohm is given by, so I1 into V. But I don't know the voltage across 20 ohm, so that I know, but I know current flowing through the 20 ohm resistor, so that I can use one more formula, that is I1 square into 20 ohm. Similarly, power consumed in 30 ohm is given by I2 square into 30. Similarly, I can get power consumed in 15 ohm is given by I square into 15. Okay, so you'll get three different powers. So I hope you'll calculate. So you calculate these values, that is nothing but 1.8 square into 20, you'll get some answer. Similarly, 1.2 square into 30, similarly 3 square into 15. If you add these three powers, you should get 243 watts. So that will be the cross verification. So this much you need to write in a examination. For circuit diagram, you'll be having 1 marks. And for the third point, to find power, 1 mark. And similarly, power at 20 ohm, 1, 1, 1 each. So that third point will be having 4 marks. Okay. And this will be having 1 mark. Second point, that is voltage across whole circuit. And current in 20 ohm, 30 ohm will be having 2 marks. So you can get 4 plus 1, 5 plus 2, 7. For circuit diagram, 1 marks, 8. So this much you need to write in a examination. You should have a clear mind while solving the problem. First, you understand the question properly. Then you solve step by step. You can easily get the answers without having any confusions. Okay. So now we'll go for the second question. 2A. So in a 2A, B, C, you can observe in a 2A, they asked one block diagram explanation of hydropower plant, then again Ohm's law and limitations, one KVL problem. So for problems, what I will do, I'll give you the equations, or just solve with the help of calculator and verify the answers. I'll tell you the steps to solve the problem. Okay. So now with the block diagram, explain hydropower plant. So you can see the block diagram. This is more than sufficient. Again, you can observe the question. They asked it for 6 marks. Two is for block diagram, 2 or 2.5 marks, and rest of the marks will be for the explanation. It has a reservoir. You need to write this block diagram. As I told again, if the diagram is wrong, explanation is right, you'll get 0 marks. So that draw the diagram neatly. So you need to write what is hydropower plant first. That is nothing but a generating station which utilizes the potential energy of high level water for the generating of electrical energy is known as hydropower plant or hydel power plant. Okay. Explanation. So you need to write these points, that is more than sufficient in the examination. So I just gave you as a point wise. If you want, you can take a screenshots. First, you need to write the working principle of hydropower plant. That is nothing but, so it is depending on the working principle of the plant, that will be depending on the conversion of hydraulic energy into electrical energy. So to get this hydroelectricity, hydroelectric power plant needs some arrangements for proper working and efficiency, so that you will be having this arrangement from reservoir to tail race. Okay, so this hydro power plant that needs a huge amount of water at sufficient head all the time. So a hydroelectric dam that is constructed across the river or lake, an artificial storage reservoir where water is stored, is placed backside of the dam. And this reservoir creates a sufficient water head. Water head is nothing but water level. A pressure tunnel. You can see now from the reservoir we'll be having a pressure tunnel. So for this pressure tunnel, so this pressure tunnel that will be placed, where it is placed in between reservoir and wall house. This pressure tunnel that will be placed in between reservoir and the wall house, and the water that will be coming from the reservoir to penstock via this tunnel. The water that will be coming from reservoir to penstock through this pressure tunnel. Okay, and there is a one automatic controlling valve that is called sluice valve that will be placed in a valve house. Here they'll be placing one sluice valve that will be placed here, and what it will do, that valve house, it has a sluice valve, so that valve house control the water flow to the power station. So it will be controlling the water, it will be controlling the water flow to the power station, and later cuts off the supply of the water in case penstock burst. Suppose if the penstock burst, it will be automatically close the valve. It will be automatically close the valve. Similarly, then we'll be having the penstock. You can easily understand this penstock is a huge steel pipe in which water that will be taken from valve house to turbine. From valve house to turbine will be taken with the help of this penstock. And also there will be one more important a block called surge tank. So this is provided just before the valve house. You can see before the valve house. This surge tank is provided just before the valve house for better regulation of water pressure in the system, to control the pressure of water. To control the pressure of water, you'll be using surge tank, because if the water continuously flowing here means again there will be pressure created, so that to release that pressure they will be having one surge tank. Few of the water, some of the water that will be flows here, then it releases pressure here. So now what happened from reservoir to what from reservoir to power station, you will be the water that will be flowing from higher end to lower end, high head to low head. So here you are placing one turbine, or then which converts this uh, mechanical, which converts this potential energy into mechanical energy, so that turbine starts to rotate, and this turbine that will be coupled to the alternator, So that turbine that converts mechanical energy into electrical energy. So that energy will be transmitting, like how I explained in a single line diagram. From here you're generating, you can call this a GES, from generating station to a receiving station to substation, substation to distribution station. Okay, so like that you are doing. Okay, so this is how this hydropower plant that works. Okay, so in these points are more than sufficient to write in examination. Okay, so if you are not understanding, I'll just glance once again. You have to write the parts that will be having. So first you need to write the working principle. So working principle of hydropower plant that will be depending on the conversion of hydraulic energy into electrical energy. Then you are explaining the parts. So it is having a water head, then reservoir. So pressure tunnel. The pressure tunnel that will be placed in between reservoir, that is nothing but reservoir and valve house. Again, the valves will be having the sluice valve to control the water, to control the water flows to the power station. Okay, if any of the construct that burns, it will automatically off the water supply. Okay, then we'll be having the surge tank to release the water pressure. Then the water that will be flowing from higher end to lower end. In the lower end, you will be placing the turbine. The turbine starts to rotate. That will be coupled to the alternator. So that produces, or else that alternator converts mechanical energy into electrical energy. Okay. And the next question is very, you can expect this question in the examination, that is a state and explain Ohm's law and its limitations. So every student knows that there will be a few expected and definite questions like Ohm's law and limitations, KVL, KCL, but you should have to write it neatly to get full marks. Okay, this is also 6 marks. Ohm's law and limitations. You need to write. It states that for constant temperature, current flowing through the two ends of a conductor is directly proportional to the voltage across the 2 points by maintaining all the physical parameters constant. And you need to write this. And again, you have to write the limitation. 6 marks is nothing but 2 marks is for statement, 4 marks is for these limitations. So these all generals, it is not applicable for non-linear devices such as semiconductors and Zener diodes. It is not applicable for non-metallic conductors, and also not applied for variable constant, variable temperature materials, and it will be not applied for the arc lamps. Okay. And the next, which is very important, they asked you to find the value of current in 2 ohm resistor. They gave one circuit diagram here. So you can observe the circuit diagram. 1 second. You can observe the circuit diagram. So in this circuit diagram, as I told, the steps to solve KVL. What is the first step? So first step is to give direction of current. Give direction of current. Before that, understand the question. Find current flowing in 2 ohm resistor. This current you need to find. Okay. So now, first, they are not given the direction of current, so that you only give the direction of current by considering voltage source as a priority. So in A to B, in a first loop, current is flowing from A to B here, lower potential to higher potential. I'm considering this as I1 is flowing here. Similarly, for 40 volts source, current is flowing from E to D, from here to here. I'm considering this current as I2. So at C junction, the current is meeting at C. Both are entering, so that current flowing through the 2 ohm resistor is I1 plus I2. Current entering is positive. So like that, you can see now the circuit diagram. First, you're giving the direction of current, then marking the polarity based on the direction of current. Okay, so here 35 volts current is flowing. I'll consider that diagram only. Here you can see First, give direction of current. So I'm giving the direction of current. I1 is flowing here and I2 is flowing here. And both the currents are meeting at C. So that at 2 ohm, I1 plus I2 is flowing. Give direction of current. Second point, mark the polarities based on the direction of current. So here you can see minus plus. Here it is plus minus. Similarly here plus minus, it is a mutual resistor. I'll write both sides plus minus. Here also it is positive and negative, negative and positive. Third, give loop direction. They are not given any loop, so that I'm considering clockwise direction, loop 1 and here loop 2. Okay, so now apply KVL to loop 1, or you can say it as A, B, C, F, A. Okay, so based on this loop direction, mark the second polarity. So second polarity is plus 35 minus 12 minus 2. So I'll write the equation plus 35 minus 12 into I1 is flowing, so that 12 into I1. Similarly, minus 2 into I1 plus I2 current is flowing here. 2 into I1 plus I2. Here I1 plus I2 is flowing, equals to 0. Then I'll rearrange 35 minus 12 I1 minus 2 I1 minus 2 I2 equals to 0. Then you can rewrite 14 I1 plus 2 I2 equals to 35. This is equation number 1 from loop 1. Similarly, apply KVL to loop 2. Apply KVL to loop 2. That is nothing but loop. Clockwise direction I am given, so that I'll write here C, D, E, F, C. See now, second polarity is positive, positive, negative. So I can rewrite now minus 40 plus 2 into I1 plus I2. Again, plus 4 into I2 is flowing there. So that 4 into I2. So rewrite here minus 40 plus 2I1 plus 2I2 plus 4I2 equals to 0. You can get 2I1 plus 6I2 equals to 40. This is equation 2. So now solve equation 1 and 2 with the help of calculator. If you don't know how to solve the equation with the help of calculator, please go through my playlist. So I uploaded one video, how to solve equations, how to solve equation using calculator. So you can go with both type of calculators, you can get the answer. Then by solving these two, you'll get the value of I1 and I2 value. So once after getting the values of I1 and I2, it's not over now. You need to find current in 2 ohm, whereas current in 2 ohm is I1 plus I2. Current in 2 ohm is I1 plus I2. Once after getting the values of I1 and I2, then you can calculate I1 plus I2. Okay. So for the important questions, so you can expect any block diagrams. So you can expect the block diagrams. So you'll be having one solar power plant and wind power plant, nuclear power plant, and also this hydropower plant. So out of these 4 block diagram, you can expect any one block diagram, so that you need to prepare all the block diagrams neatly. If the block diagram is wrong, explanation is right, you'll get 0 marks. And as per my knowledge, so you can expect Ohm's law and limitations, KVL, KCL, KVL and KCL, and also you can expect single line diagram, single line diagram. Obviously, resistance in series parallel combination, series parallel combination of registers problems. Definitely you can get one problem. One problem from this, another problem from KVL and KCL. KVL and KCL problem. So 1A, 1B, C. Two theory questions, one problem. 2A, 2B, 2C. Two theory questions, one problem. Or else two problems, one theory question. So it depends. So anyhow, we'll be having a simple numerical problems. So nothing to worry. You can easily crack the examination if you prepared very well the block diagrams as well as a single line diagram and practice more problems on DC circuits, that is Ohm's law problems. It is nothing but series parallel combination. They will ask you to find the value of branch currents, and they asked you to find unknown value of voltage. They will ask you to find power and power drawn by each resistors. Okay, so these are the important questions that you can expect in examination. Okay, so now this is about the model question paper of module F1. So if you are having any doubts, feel free to write in a comment box. Give me a suggestion if I'm going fast also. So I hope it will helps you a lot in the examination. Please make use of this. And also, if you really like this video, kindly support and also share to your friends maximum, and also please do a subscribe, like, for this EE Academy channel to learn happily. Okay, thank you so much. Once again, I'll come back with a module 2 question paper very soon. Have a nice day. Thank you.